we're going to learn how to solve equations that have an absolute value. We've already discussed that the absolute value of every number has two solutions. For example, the absolute value of +5 is 5, and so is the absolute value of -5. So there are two numbers that have the same absolute value. So how do we apply this to an equation? The first thing we want to do is isolate the absolute value. If there's any numbers on the outside of the absolute value, we need to move it to the opposite side of the equation. After we do that, we want to split it into two separate equations. When we look at this example, we have the absolute value of 5 minus 2x equals 11. Well, there are actually two different numbers that we can put in as absolute value that have an absolute value of 11. The first is +11, and the second, it would be a -11. And that's why we split the equation into two separate equations and solve each of the equations. Well, let's look at this from a graphic standpoint. So in example 1, we're going to solve this equation, and we're going to do it both graphically and also analytically. So we're solving the absolute value of x plus 4 plus 1 is equal to 3. And we're going to do that by graphing a system of equations. We've already learned that a system is two or more graphs on the same coordinate plane. The graph that you already see is the graph of x plus 4 plus 1. Okay, and now we're also going to graph 3. So what we're doing essentially is graphing y equals the absolute value of x plus 4 plus 1, and also y equals 3. And we're going to see where these two graphs intersect. So we already have the graph of the absolute value. And now let's graph y equals 3, which is a horizontal line. Notice that that horizontal line crosses through the absolute value in two different places. So this is my first solution, and this is my second solution. So my first solution occurs where x is equal to -6. And my second solution occurs where x is equal to -2. So now let's solve it analytically. So remember, before we separate, we are going to isolate. So I am going to isolate this absolute value by subtracting 1. When I subtract the 1, I have the absolute value of x plus 4 is equal to 2. And now we're ready to separate it. There are two different numbers that I can put in this bracket that have an absolute value of 2. The first one is +2, and the second one is -2. So we're going to separate it. 2x plus 4 equals +2, and x plus 4 equals -2. And when we solve both of these equations, we're going to subtract 4. And notice that we actually get the exact two answers that we got when we solved it graphically. That are two x values where the absolute value graph and the horizontal line intersect are at -2 and also -6. Okay, so now let's look at example 2. Let's solve this one analytically. The first step is isolate. And when we look at this example, we notice that this absolute value is already isolated. We don't have any numbers in front of the absolute value, or any numbers behind the absolute value. So we're ready to separate it. My first equation is negative 2x minus 4 is equal to 14 because the numbers that I can put inside of this bracket that have an absolute value of 14 are positive 14 and negative 14. So my second equation will be negative 2x minus 4 equals negative 14. So now we're ready to solve both of these analytically. So I'm going to add the 4 to both sides, which gives me negative 2x equals 18. And then I'm going to divide by negative 2. So the first location will be at x equals negative 9. That is our first x value where we will have an intersection. Let's do the same thing with our second equation. First, we're going to add 4. And then we're going to divide it by negative 2. So our second solution is x equals positive 5. So the two solutions to example 2 are negative 9 and positive 5. Let's do one more. Okay. So again, we need to start by isolating. So the first thing I'm going to do in order to isolate is add that k value. So I'm going to add the 8. We cannot separate until we isolate. That's really important. And now I'm going to divide the 2/3. Remember, when we divide by a fraction, we're really multiplying by the reciprocal. So I'm really just multiplying both sides by 3/2. So that gives me the absolute value of 7x minus 6 is going to equal 36. So now that we have isolated, we are ready to separate. What two numbers can I put inside of the absolute value that will give an answer of positive 36? Well, the first is 7x minus 6 equals 36 because 36 has an absolute value of 36. The other number that has an absolute value of 36 is negative 36. So we're going to separate it. And our second equation is 7x minus 6 equals negative 36. So now we're ready to solve. So we have 7x equals 42. And then we're going to divide by 7. So my first solution is x equals 6. And let's do the same thing with our second equation. We're going to add the 6. And that's going to give us 7x equals negative 30. And then we're going to divide by 7. And we're left with our second solution, which we will leave as a fraction. And that will be negative 30/7.